We're here to take logic to the next level. We talk about Venn diagrams, probably something you're familiar with, maybe in previous math classes or in science classes. So what a Venn diagram is, it's a picture, it's a diagram, and it shows how two sets of things are related, or two sets or more really, because we're going to talk about three sets as well. And some of the ways we use these diagrams to represent these sets is in these three ways. If we have a circle, and we usually use circles, if we have a circle contained in another circle, it means all. If we have two circles not touching or intersecting at all, it means none. And then a little bit of an overlap like this one will mean some. And that's going to make a lot more sense when we do some examples. So just know something inside of something's all, two circles separately means none, and some overlap is going to tell us some. So it means they share some qualities. So let's look at a couple examples. We're going to take these Venn diagrams and we're going to write some conditional statements. So we can see that on the one on the left here, we have a circle with flipped class, and we have a circle with geometry. So you might know that at our school right now we have two flipped classes, and both of them are geometry classes. And so shout out to Mr. Munson. And so that if you can imagine all the people at Hilton in this circle, in this little circle, that are in a flipped classroom, we'll put them all in there. They would also be contained in the circle of all the students who are taking geometry at Hilton. So we can write a conditional statement here. If you are in a flipped class, then you are in geometry. So if I found any student in Hilton right now that's in a flipped classroom, they would also be taking geometry, and they would either have me or Mr. Munson. And we can do the same thing over here on the right. Imagine we took all the soccer players, not necessarily at our school, but anywhere, and we put them all in this circle. They would also be in this bigger circle of all of the athletes. So a soccer player is considered an athlete. So we can write, if you are a soccer player, then you are an athlete. So in the previous slide, when I told you what a Venn diagram was, we talked about relating sets. So in this case, we've related two sets. We have a set of soccer players and a set of athletes, and they overlap in that all the people in the soccer player set are in the athlete set. And you should remember, hopefully, from previous math classes, that a set is just a group. So the group of soccer players is in the group of athletes. Another thing we can do with Venn diagrams is we can take a statement, we can take some information, and we can draw a Venn diagram to represent that. So I always like to use this one. I hope that's not true. No students like Mr. P. So the two groups we have here are students and people who like Mr. P. So if we have the word no, that means our two groups are not going to overlap at all. So we will have a group of students and we will have a group of people who like Mr. P. I hope there are some people in that group. And since they're not overlapping, that represents that no students are people who like Mr. P. Over here we have some students like soccer. Again, from our first page when we first start talking about Venn diagrams. Some means we're going to have some overlap, but not all. So we'll have two groups, people who like soccer and we'll have another group that overlaps here, students. So all the people that are in this space where they overlap, those are the people who like soccer and are students. So there's all our students that like soccer, whether they watch it, play FIFA. Here we have a if-then statement. The conditional statements, if-then, will be represented like we did on the previous slide, where we have one circle in a bigger circle. If you want to graduate, then you must pass geometry, something that we all have to do. So if you want to graduate, we'll shorten that, and you must pass geometry. So all my people in the wanting to graduate circle are also part of the must pass geometry circle. Okay, so none, separated, some, overlap, all, or a conditional, they're going to be one inside the other. The last way we are going to use Venn diagrams is actually to draw a picture and find out a number, solve a problem. So this is a bit long, take a second to read it, and we'll talk about how to go about solving this. So here we're talking about a vet, and he's talking to 26 of the people who take their animals there. And we can see they have some number of dogs, cats, and fish. So we have three groups here, so three sets of animals, or maybe three sets of people who have these animals. I'm going to use real circles this time. And since I have three, I need three circles. So we'll also find out by reading this that some people have dogs and cats, some have dogs and fish, and some have cats and fish. And we're looking to see how many have none. So if we have a dog circle, some people have dogs and cats. Some people have cats and fish. Some people have dogs and fish. So we're going to have these three things overlapping. Kind of looks like the Olympic rings moved around a bit. And we can see that there's a space here in the middle where they all three overlap. At the end here we say no one has all three kinds of pets. So let's start this problem by putting a big 0 in there, meaning there are no patrons in this part of the Venn diagram. 0 people have dogs and cats. So now let's go use our numbers. 14 have dogs, 10 have cats, 5 have fish. We know 4 have dogs and cats. So the place where the dog circle and the cat circle overlap is our 4 people who have both of those. 3 have dogs and fish, so where the dog and the fish circles overlap, that's where we have 3 people. Those 3 people have both animals. And 1 person has cats and fish. That goes there where those 2 circles overlap. So we're going to look at what goes in the rest of the circle. So how many people have just dogs? How many people have just cats? How many people have just fish? So we know that 14 people had dogs. 3 of them have fish. 4 of them also have cats. So we already have taken into account 7 of the dog owners. So since there's 14 total dog owners, that means there are 7 left that only have dogs. Over here, we know that 10 people have cats as pets. We've taken into account 4 of them who also have dogs, 1 person who also has fish. So that's 5. That means there are 5 people left over who only have cats. And we know that 5 people have fish. We've already taken into account the 3 fish owners that have dogs, the 1 fish owner that also has a cat. So if there's 5 total, we have 1 left over that has only fish. So now in the end, we want to know how many people don't have dogs, cats, or fish. Maybe they have lizards or some other type of pet. We originally had 26 people who go to the vet. Let's count up all these in here to figure out how many people have these 3 kinds of pets. So we got 10, 14, 15, 20, 21. So in these 3 circles, there are 21 people. There are 26 overall patrons that the vet interviewed, so that means 5 people don't have any of these kinds of pets. So we can see how Venn diagram can help us kind of come to that conclusion. So I want you to go ahead and try these 2. I want you to write an if-then statement for this one. You might need to pause and copy this down because I need to scroll for you. And I want you to draw a Venn diagram for this statement, some people like steak. So again, you might have to pause here to do number 1, and then pause and do number 2.